in the aid of farmers. Now, e-technology in agriculture refers to the usage of internet and related digital and information technologies in managing the business of agriculture. Now, for e-technology, we can have connected livestock, whereby sensors monitor animal health and food intake, and then they send alerts on health anomalies or reduction in food or water intake. Now, smart drones can be used to conduct survey fields, map weeds, yield, and soil variations, etc. Enable application of inputs and map productivity. Drones are also used for applying pesticides and herbicides. Similarly, we can use autonomous tractors, weather forecast to enable decisions about when to plant, what area and crop variety to plant, and when to apply fertilizers and when to harvest. Regarding that, we have soil sensors, fleet of agribots, crowdsourcing, which establishes agribusiness communities of practice to share insights or videos or pictures, also share information with other farmers in rural areas. The role of farming data is also that vast form data is stored on cloud, fed to advanced analytic engines, and then used by agro input companies to customize servicing and farmers to make timely operating decisions to enhance yield and profitability. Now, information and communication technology led to precision farming, which is an approach where inputs are utilized in precise amounts to get increased average yields. Now, moving on to National E-Governance Plan in Agriculture, that is NEGPA. Now, NEGPA was introduced for the rapid growth in agriculture sector with the help of information and communication technologies. Key objectives of NEGPA are bringing farmer-centric plans and service orientation program, improving outreach of extension services, providing farmers with greater access to information as well as services coming under the scheme with the help of crop cycle program, enhancement and integration of existing information communication technologies initiative of both center as well as the state governments, redesigning progress processes to enhance their efficiency and effectiveness, effectively managing various schemes coming under the Department of Agriculture Corporation, promoting common framework for project across different states. Now, key benefits of any GPA project are that farmers get access to information and various services. Online agricultural service would be provided across states. Grievances of the farmers would be addressed in a faster and more efficient way. Provision of use of email services across the department. Now, the department would become more transparent and efficient due to the use of ICT. The farmers will be able to give feedback to decision makers, and various government schemes made for farmers would be monitored in a better and more efficient way. Resources can also be managed more efficiently and effectively, and farmers can reap higher benefits and profitability. Stakeholders can use informations more effectively for decision making, and the project lays foundation for development of various e-businesses in agriculture sector. Now, role of ICT in agriculture can be condensed into information dissemination, increasing the productivity through precision farming, efficient agricultural marketing, new employment opportunities, effective monitoring and analysis, effective governance, government service delivery, and also it can be used in insurance processes. Now, information dissemination throughout crop cycle through technologies like satellite communication, GIS, video and mobile phones, etc., regarding weather conditions, input requirements like seed, fertilizer, soil health, etc. For example, DD Kisan. Now, increasing productivity through precision farming. For example, digital spectrogram technology can assess soil health without transmitting the soil physically to a lab by merely taking a spectral image of a soil sample. Now, the spectral analysis can diagnose the contents of the sample and communicate results to the farmers almost instantly. This will enable farmers to make an informed choice regarding the agricultural input they have to put in their fields. Now, efficient agriculture marketing by providing regular updates regarding prices for commodities, inputs, consumer demands, so that farmers could base their crop production depending on market demands, for example, ENAM. Now, new employment opportunities will be created in the digital field, thus reducing instances of disguised unemployment. Effective monitoring and analysis of agricultural performance through ICT to reduce losses at various levels of supply chain. Now, ICT tools will increase effectiveness of government service delivery in quick estimation and timely compensation to farmers in wake of disasters. PM Fasal Bima Yojana assesses crop damage to the crops for insurance purposes through satellite and drone imagery. Using ICT tools will improve accuracy while estimating compensation claims under such insurance schemes. Now, government has taken several ICT initiatives to improve extension services in agriculture, like agricultural services like pesticides registration, soil health testing, laboratories, etc. Mobile application for increasing awareness by providing information like Kisan Suvidha, whereby farmers can seek advisories on their agricultural problems directly from agricultural scientists. Now, modernization of land records using blockchain technologies have been taken in states like Andhra Pradesh. ENAM has been launched to create a unified national market for agricultural commodities. Now, web portals have been launched for farmers' convenience. Example, Crop Insurance Portal provides complete information related to crop insurance schemes. Now, the use of drone technology in agriculture. An agricultural drone is an unmanned aerial vehicle used to help optimize agricultural operations, increase crop production, and monitor crop growth. Now, sensors and digital imaging capabilities can give farmers a richer picture of their fields. Using an agricultural drone and gathering information from it may prove useful in improving crop yields and farm efficiency. With the data that drones record from the crops, the farmers are able to analyze their crops and make educated decisions on how to proceed given the accurate crop information. Now, the aerial view provided by a drone can reveal many issues like irrigation problems, soil variations, pest and fungal infections. Multispectral images show a near infrared view as well as visual spectrum view. The combination shows the farmer the difference between healthy and unhealthy plants, a difference not always clearly visible to human eyes. Thus, these views can assist in assessing crop growth and production. Crops can be surveyed at any time using agricultural drones, allowing for rapid identification of problems. Another major benefit of using drone technology is that it can be used to monitor and control the use of pesticides properly. This allows minimizing the environmental impact of pesticides. Now, big data in agriculture. In agriculture, big data is often viewed as a combination of technology and analytics that can collect and compile novel data and process it in a more useful and timely way to assist decision making. Now, according to agricultural funders, the big data comprises capturing relevant data from a huge number of sources, collecting it today, and translating it into actionable information to improve business processes and solve problems at scale and speed. Now, data helps debt laden farmers, insurance agencies, loan banks, seed companies, machine industry, and every big and small player. Data analysis not only creates greater awareness and more accurate knowledge, but also can plug the lacuna in supply and marketing chain of the industry. Now, big data can be useful in agriculture in the following ways. It can help in the development of new seed traits, precision farming, food tracking, effect on supply chain, commodity price forecasting. Now, development of new seed traits assess to plant genome with new ways to measure, map, and drive information, better product. Now, big data takes advantage of information derived through precision farming in aggregate over many farms. The resulting analytics, insights, and better decisions can then be deployed through precision farming techniques. Now, use of sensors and analytics to prevent spoilage and foodborne illnesses. Effect on supply chain. Scientific shifts in the supply chain of seed, crop input, and food driven by democratization of technology and information. Commodity price forecasting. The price of commodities fluctuates significantly. The forecasting information will help farmers know the price of agricultural commodities in advance and use this input to decide as to which crop to sow. Government can also use the data while taking decisions on fixing MSP, import export duties, and other policy decisions. Now, moving on to Internet of Things in agriculture. IoT in agriculture uses robots, drones, remote sensors, and other computer imaging combined with continuously progressing machine learning and analytical tools for monitoring crops, surveying, and mapping the fields, and provide data to farmers for rational farm management plans to save both time and money. Now, application of IoT in agriculture are robotics, drones, remote sensing, and computer imaging. Now, weeding robots, harvesting robots, material handling robots, they can lift heavy materials and perform tasks like plant spacing with high accuracy, therefore optimizing the space and plant quality, and reducing production costs. Now, drones equipped with cameras and sensors are used for imaging, mapping, and surveying the farms. Remote sensing is used for crop monitoring, determining the weather patterns, and analyzing soil quality. Computer imaging involves the use of sensor cameras installed at different corners of the farm or drones equipped with cameras to produce images which undergo digital image processing. Image processing views the images in different spectral intensities such as infrared, compares the images obtained over a period of time and detects anomalies, thus analyzing limiting factors and help better management of farms. Now, artificial intelligence in agriculture. AI refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their action. An Accenture study says that digital farming and connected farm services can impact 70 million Indian farmers in 2020, adding approximately 9 billion US dollars to farmers' income. Niti Aayog, in its National Strategy for Artificial Intelligence, mentions the following significance of AI in agriculture. It can be used in soil health monitoring and restoration, crop health monitoring, and providing real time action advisories to farmers, increasing efficiencies of farm mechanization, increasing the share of price realization to producers, and AI for precision farming. Now, image recognition and deep learning models have enabled distributed soil health monitoring without the need of laboratory testing infrastructure. Example: Berlin based agri tech startup Peat has developed a deep learning application called Plantix that reportedly identifies potential defects and nutrient deficiencies in the soil. Now, varying weather patterns such as increase in temperature, changes in precipitation level, and groundwater densities can affect farmers, especially in the rain-fed areas of the country. AI can be used to predict advisories for sowing, pest control, and input control to ensure increased income and provide stability for the agricultural community. Now, image classification tools combined with remote and local sense data can bring a revolutionary change in utilizing and efficiencies of farm machinery. In areas of weed removal, early disease detection, produce harvesting, and grading. Example: Microsoft, in collaboration with ICRISAT, developed an AI sowing app which sends sowing advisories to participating farmers on optimal date to sow. Now, current low level of price realization to farmers are primarily due to ineffective price discovery and dissemination mechanism, supply chain intermediary inefficiencies, and local regulations. Predictive analytics using AI tools can bring more accurate supply and demand information to farmers, thus reducing information asymmetry between the farmers and the intermediaries. Now, Niti Aayog and IBM have partnered to develop a crop yield prediction model using AI to provide real time advisories to farmer. IBM's AI model for predictive insights to improve crop productivity, soil yield, control agricultural inputs, and early warning on pest and disease outbreak will use data from remote sensing, which ISRO will provide, soil health cards, IMD's weather predictions, and soil moisture temperatures, crop phenology, etc., to give accurate prescriptions to farmers. Now, blockchain technology in agriculture. Blockchain technology is most simply defined as decentralized distributed ledger that can record the origin of a digital asset. Now, the goal of blockchain is to allow digital information to be recorded and distributed but not edited. Use of blockchain technology in agriculture is as follows: reducing transaction cost, agriculture, good agricultural practices, authentic supply chain, and land records modernization. Now, a digital trading platform based on blockchain technology directly connects each transacting party to the same dataset in transparent manner. This reduces the transaction cost and creates financial security and supply chain transparency. Now, blockchain technology in the new agricultural sector can be used to record interlinked field practices such as integrated nutrient management, confirmed good agricultural practices, validate resource use efficiencies, build traceability for produce from farm to work, and prevent price extortion and delayed payments. Now, the technology can be used to validate authenticity of planting material by keeping a record of high resolution images of the material in transit, provide similar traceability of other items from source to farm, record every input until the point of consumption at farm level, etc. This immutable record keeping system can build checks in the input and output supply system. Since blockchain relies on a distributed ledger, it is considered more secure and it makes it difficult for anyone to compromise the integrity of the data. Now, Indian states are digitizing land records with blockchain technology to establish property rights as land is critical input to agriculture. Moving on to robotics in agriculture. Now, robotics has the following uses: nursery management, agri input application, grading and sorting, robotic sensors, veterinary use, drones, greenhouses. Now, robotics are commonly used for nursery in nurseries for seeding, potting, and harvesting of plants. Robots can undertake targeted spraying of pesticides and fertilizers, leading to precision farming. Grading and sorting actions are performed by robots in warehouses and cold storage to automatically package, label, and move the boxes containing agricultural produce to the next stage of handling. Now, these can be used for crop and soil health monitoring, assessing crop loss, incidences of pest and disease, etc. Now, robots are used in dairy facilities, as in the case of feeding and milking machines. Similarly, in fisheries sector, automated feeders and pond aeration systems are used. Now, drone is a type of robot used for a variety of purposes like pesticide spraying, monitoring crop health, etc. In greenhouses, rain and light sensing robotic arms can automatically retract or cover the roof as per the need. Now, use of space technology in agriculture. The Ministry of Agriculture and Farmers Welfare has been proactive in using space technology in agriculture sector for its various programs, such as FASL, which is forecasting agricultural output using space, agrometeorology, and land-based observations project. Chaman, which is coordinated project program on horticulture assessment and management using geoinformatics project. Nadam, which is National Agricultural Drought Assessment and Monitoring System project. Rice fallow area mapping and intensification. Geotagging of infrastructure and assets created under Rashtra Krishi Vikas Yojana and crop insurance. Now, applications of space technology in agriculture are as follows. The space technologies helps getting fast, unbiased information about crop situation in the country. It provides digital data which can help in various analysis. This data can be used for various programs which need information on crop type, crop area estimation, crop condition, crop damage, crop growth, etc. The Department of Agriculture Cooperation and Farmers Welfare has launched Kisan, which is crop insurance using space technology and geoinformatics project. The project envisages use of high resolution remote sensing data for optimal crop cutting experiment planning and improving yield estimation. It can be used for mapping groundwater resources at high resolution. Space technology can be used for operationalization of early warning systems on weather patterns like rain and temperature for deciding crop to be sown, irrigation, fertilizer application, spray of pesticides, etc., so as to facilitate farmers and informed cultivator. Now, satellite communication can be used for farmers' training and advisory, that is, tele-agri-medicine. Satellite navigation systems such as Gagan and Navik can be used for precision farming and geotagging of resources. Real time and accurate assessment of losses caused by natural disasters like floods, droughts, cyclones, etc., can be done for better risk management and implementation of crop insurance. Now, remote sensing in agriculture. Remote sensing makes use of visible, near infrared, short-wave infrared sensors to detect and monitor the physical characteristics of an area measured by its reflected and emitted radiations at a distance, typically from a satellite or an aircraft, which can be a drone as well. Now, use of remote sensing in agriculture is as follows. Remote sensing can assist in crop classification. Acreage under cultivation could be estimated in order to arrive at production estimates. GIS tools can accurately collect the data on crop health and disease. Chlorophyll content in vegetation of a specific location can be measured. Remote sensing gives data on soil moisture, helps in determining the quantity of moisture in the soil, and hence the type of crop that can be grown in the soil. Now, greenhouse gas emissions from rice paddies of a specific location can be monitored. Crop losses can be monitored, which would help in verifying insurance claims by the farmers. Now, remote sensing can accurately monitor biodiversity and impact of agroecology. Now, advantages and challenges in the spread of e-technology. Advantages of e-technology in powering factor is that it can help with cost optimization, transparency, that is DBT through Jan Dhan Yojana. Having necessary information at disposal through e-services will enable small and marginal farmers to take informed decision making. Use of blockchain technology will ensure integrity and transparency in the overall system, minimize corruption by preventing leakages, breaking linguistic and diversity barriers by using AI chatbots. Now, challenges with respect to e-technology are digital illiteracy, privacy issues, poor digital infrastructures like internet penetration, software issues, etc. Many extension and advisory services are not available in the local language. Huge investment is required to set up e-technology related infrastructure, at least in the initial phase. Now, as per the latest report by Internet Mobile Association of India, India has 227 million active internet users. With rising penetration of ICT in India, there is a scope for using this potential to digitally empower the farmers of a country, which will transform the agricultural sector and play an important role in doubling the farmers' income. That'll be it.